reactions in lab, there are two ways to mix the chemicals. One, you can mix the chemicals stoichiometrically. Stoichiometric just means that you have just the right amount. Just the right amount. So, looking at this reaction, number 44, we're taking solid zinc and reacting with 2 HCl to form zinc chloride and hydrogen gas. And so just the right amount means that for every mole of zinc, you're going to add 2 moles of HCl. No more, no less. But that's hard to do in lab. In lab, it's hard to mix things. Exactly. And so, let's say 1 mole of zinc is 6.022 times 10 to the 23rd atom. 2 moles of HCl would have 2 times that, so it would be 12.04 times 10 to the 23rd HCl molecules. And so, are you going to measure those out exactly? No. It's too hard to do. And so if we had just the right amount, it would react stoichiometrically. So all the zinc would react, all the HCl would react. But typically to save time, what we'll do is we won't do it stoichiometrically. We'll do it excess reactant and limiting reactant. Call this ER or excess, and then this would be the LR. And so it depends on which one we want to have react completely. What we'll typically do is we'll have a limited amount of zinc, and then we'll add extra HCl. And the extra HCl will be used to make sure all the zinc reacts. So that's typically what's done, but that's not shown here. This is what's shown here. In flask 1, they let this react, and so they put in some zinc here. They let all of it react. Well, all of it didn't react. But what has happened is all the HCl reacted. There's no more HCl to react, therefore there's no more hydrogen gas being generated. Hydrogen gas that's generated is collected in the plume here. And so this is a case where we have too much zinc, not enough HCl. In flask 3 over here, we have too much HCl, not enough zinc. So there wasn't enough zinc, so this reaction stopped short. In flask 2, what they're trying to show is it's stoichiometric. All the zinc is reacted, and all the HCl is reacted. And so what they're asking here is this: explain the observed results. So in flask 1, they put in 6.10 grams of zinc with the balloon completely inflated, but there's unreacted zinc that remains. In flask 2, there's no zinc that remains, and the balloon is completely inflated. So that means all the HCl has reacted the same amount as this. And therefore, we have a stoichiometric mixture. In flask 3, the balloon was incompletely inflated, and there's no more zinc. That means not all the HCl reacted. There's still some leftover HCl, but there wasn't enough zinc to react at all. And so that's flask 3. So these are just examples of excess and limiting. Here we have excess zinc. Over here we have excess HCl. Not enough zinc. All 3 flasks have the same amount of HCl to start with. And flask 2 is just the right amount. Just the right amounts of stoichiometric. So limiting reactant problems, let's take a look at one from your homework. Here. Limiting reactant problems, typically we're going to be given the amounts of more than one reactant. So in this reaction, we have 1.63 grams of barium chloride is added to a solution containing 2.40 grams of sodium bromine. And so the reaction here is barium chloride plus sodium chromate yields, well, what does this yield? Barium chromate. Barium chromate and sodium chloride. Need 2 sodium chlorides to balance it out. Chromates are all insoluble except for group 1 and ammonium. So this is an insoluble solid, which is going to be a PPT. So that will be our driving force here. Find the mass in grams of barium chromate that can precipitate. And so what we have is we have 2 ingredients to form barium chromate. We have 1.63 grams of barium chloride and 2.40 grams of sodium chromate. And so this is like asking this kind of question. This is like, let's say you're making cookies and you have, let's say you have 3 bags of flour and 1 cup of sugar. How many cookies can you make from 3 bags of flour and 1 cup of sugar? Well, if you have 3 bags of flour, then that can make a certain number of cookies. And if you have 1 cup of sugar, that can make a certain number of cookies. And so thinking about it, is that just the right amount? Is that stoichiometric? 1 cup of sugar and 3 bags of flour? No, we're probably dealing with excess limiting scenario. And whenever we're given multiple ingredients, then we are dealing with excess limiting. In fact, you probably have too much of one ingredient, not enough of the other. So which one do you think you have too much of? Maybe too much flour, right? Not enough sugar, most likely. Most likely, but sometimes you can't tell because when I look at this, I don't know which one I have too much of. Do I have too much barium chloride? Or too much of the sodium chromate? And so when we have a problem like this, what we do is we'll ignore one. And so this would be like three bags of flour. You know, how many cookies can you get from 3 bags of flour? That's what we're going to figure out. Except we're not after cookies, we're after barium chromate. So how much barium chromate can we get from this first ingredient? And so we start off with 1.63 grams of barium chloride, and then what we'll do is we'll go to moles of barium chloride. From moles of barium chloride, we'll go to moles of barium chromate. And then from moles of barium chromate, we're going to go to grams of barium chromate. And so this is called the yield from the first ingredient. This is going to be yield from barium chloride. And so how many cookies can we make from the first ingredient? Well, that's this yield from barium chloride. And the yield is going to be in grams in this case, so let's go ahead and calculate it. It's going to be 1.63 grams of barium chloride. And then we're going to convert it to moles. And so barium, we need the molar mass. Barium is 137.33. 137.33. And then chlorine, we've got 2 chlorines. Each chlorine is 35.45. So this is going to give us 70.90. So this is 328, 208.23. And so a mole of barium chloride weighs 208.23 grams. And so the grams of barium chloride cancel. That leaves us with moles of barium chloride. And then for every mole of barium chloride, we're going to form 1 mole of barium chromate. So it's a 1-to-1 mole ratio. 1 mole of barium chromate forms for every 1 mole of barium chloride. And then we need the molar mass of barium chromate. Barium, 137.33. chromium. Chromium is 5200, rounded to 52.00, and then 4 oxygens. 4 oxygens is 4 times 16.00 equals 64.00. That's 3, 3, 9, 13. Did I get that right? 253.33. So 253.33 grams barium chromate for every mole. Barium chromate. The mole. Excuse me. Let's see how many grams that comes out to. 1.66. No, 1.63. 1.63 divided by 208. 123 times 253.33. 1.93. So from the first ingredient, we should be able to make 1.93 grams product. And so this would be like the flour, but we got to make sure we have enough of the second ingredient. So we're going to do exactly the same thing with the second ingredient. The second ingredient is 2.40 grams of sodium chromate. And so we'll go from grams of sodium chromate to moles of sodium chromate. And from moles of sodium chromate, we'll go to moles of barium chromate. And from moles of barium chromate, we'll figure out how many grams of barium chromate we get. So our next calculation is 2. Look, what is the yield from sodium chromate? So we're starting off with 2.40 grams of sodium chromate, and then we'll go to moles. So we have 2 sodiums. That's 2 times the sodium's whole mass, 2299. 2299, 45, 98. 1 chromium, 52.00, and 4 oxygens, 64. It's going to be 98, 11. 161.98. All right, so 2.40 grams of sodium chromate, we'll convert that to moles of sodium chromate. 1 mole of sodium chromate weighs 161.98 grams. Grams of sodium chromate cancels. Then we're going to go from moles of sodium chromate to moles of barium chromate. 1 mole of barium chromate for every 1 mole of sodium chromate. And then we'll figure out the mass. It's 253.33 grams of barium chromate for every mole. Out. That leaves us with grams of barium chromate. So it's going to be 2.4 divided by 161.98 times 253.33, 3.753. So this is like, how many grams of barium chromate can I bake? Well, assuming I use all the first ingredient, I can get 1.983. If I use all the second ingredient, I can get 3.753. So how many am I able to make? Well, this is like the thing with the sugar. Once you run out of sugar, then you can't make any more cookies. And so once we run out of one of these ingredients, we can't make any more. And so which ingredient are we going to run out of first?
Barium chloride.
Barium chloride. Once we run out of all 1.63 grams, then we don't have any more than 1.63 grams. If we use all 1.63 grams, then the maximum amount that I'm going to get is 1.983. There's no way I can get all the way here. And so the next part of this is we're going to label this. This will be part 4. Okay, what we're going to do is we're going to pick the smaller amount. The smaller amount is called the theoretical yield. I'm going to pick this. This is going to be my theoretical yield, or Ty. In theory, the most I can make is 1.983 because at that point, all of my barium chloride has been consumed. There's no more barium chloride. Even though I have plenty of sodium chromate, I don't have enough barium chloride to react with that. And so this is my theoretical yield. If that's my theoretical yield, then what we call this is we call this the limiting reagent, the LR. And that means that this has got to be the excess reagent, the ER, excess reagent. And so the excess I got too much of. That's not all going to react. I'm not going to form my 3 ones. Sorry, this is number 3, not number 4. Okay, that means I'm gonna waste. If I dump in did I need all 2.40 grams of this? No, I didn't need all 2.40 grams of this. That means I'm gonna waste a lot of it. It's like, it's not going to be usable, some of it. And so the last calculation we're going to do here is this. For this particular, we're going to do one more on top of this, but for this particular problem, also determine which reactant was in excess, the sodium chromate, as well as the mass in grams in excess of the amount required for the limiting reagent. And so number 4 here, we're going to calculate the amount of unreacted excess reagent. The amount of unreacted excess reagent is equal to the initial amount minus the amount consumed by the limiting reactant LR. And so initially we're given 2.40 grams of sodium chromate. We aren't going to use all 2.40 grams. How much are we going to use? Well, the amount we're going to use is the amount that's needed to react with 1.63 grams of barium chloride. And so we start off with the limiting reagent, which is 1.63 grams of barium chloride here. And so in this particular problem, what we're going to do is start off with grams of barium chloride, go from grams of barium chloride to moles of barium chloride. From moles of barium chloride, we're going to go to moles of sodium chromate. moles of sodium chromate, we're going to go to grams of sodium chromate. And this is the number of grams of sodium chromate required to react with 1.63 grams of barium chloride. And so we'll have to go from grams of barium chloride to moles of barium chloride. This is 20823. 20823. Barium chloride per mole. Okay, and then from moles of barium chloride to moles of sodium chromate, mole ratio is 1 to 1. So 1 mole of sodium chromate is required for every 1 mole of barium chloride. And then we need the molar mass of sodium chromate, which is 161.98. 161.98 grams of sodium chromate per mole of sodium chromate. So what does that come out to? So it's going to come out to 2.40 grams minus how many grams we got there? So let's see, 1.63 grams of barium chloride is going to require how many? So 1.63 divided by 208. 208.23 times 161.98. 1.269 minus 1.269 grams. Okay, so this is the initial amount, this is the amount consumed by the limiting reactant. So initial minus grams consumed by the LR. 1.130 grams. Excess reactant remaining. So this is the unreacted. So, you know, I dumped, in this particular reaction, they dumped in an extra 1.13 grams. It's too much. Let's take a look. And so this is again what they did here in this particular problem. If you look at, what is this step 1? This is called the smaller amount method. The smaller amount dictates the yield. And so first they calculated the amount of product that they're going to get from 1.63 grams of barium chloride, assuming they have plenty of everything else. And they came out 1.98 grams. The next step is they calculate the yield from sodium chromate, which gave a much higher yield, 3.75. But there's no way to get 3.75 because they're going to run out of barium chloride well before then. But we'll run out once we hit 1.98 grams. Once we hit 1.98, we can't go to 1.99 grams because all of 1.63 grams. Now, if we're given more, then yeah. Okay, barium chloride is a limiting reactant because that gave the smaller yield. The yield is a smaller amount, 1.98 grams. This 1.98 grams is called the theoretical yield. It's impossible to make that. So if you have 3 bags of flour, it's going to be impossible to make that many cookies if you don't have enough sugar. Right, so that's 1, 2, and 3. And then step 4, we calculate this. What are they doing here? What they're doing is they're figuring out how many grams of sodium chromate are required to react with 1.63 grams of barium chloride. And so this is the amount that's going to be consumed. 1.27 grams of sodium chromate will be consumed. However, we were given 2.40, well more than what was required. And so this is the initial minus the amount that was used or consumed, and this is the amount that's left over, 1.13 grams, which we got here. The amount left over. So that's a typical limiting reactant problem. take a look at number 46. Number 46, carbon dioxide can be removed from the air by reaction with potassium hydroxide. So if we look at this, this is a Lewis acid-base reaction. CO2 is a Lewis acid. Potassium hydroxide is a Lewis base. It's also a Bronsted base. This is going to form potassium carbonate and water. It's 15.6 grams of carbon dioxide, so we're given ingredient 1 here, 15.6 grams. Reacts with 43.0 grams of potassium hydroxide, so we're given ingredient 2. So we're given more than the quantities of more than one ingredient. So that means it's limiting reactant. We don't know which one of these is. Maybe it's stoichiometric, maybe it's just the right amount. Maybe it's not. Maybe one of these is in excess, the other is in limiting. What mass of potassium carbonate will be formed? And so I don't know, is that the 3 bags of flour? This is one we got for sugar, or vice versa? What amount of excess reactant remains after the reaction is complete? And so why don't you try this one here? So what would step 1 be in the limiting reactant problem? First, you got to recognize it. If we're given multiple ingredients, then it's always going to be limiting reactant. And so what's the first step in limiting reactant? First step would be to
take the smaller amount and convert it to
well, first we have to calculate the smaller amount. So the first step would be to calculate the yield. Yeah, and so they're interested in potassium carbonate. If they just wanted the limiting reactant, then I'd probably pick water because it's easier to calculate the molar mass of water, potassium carbonate. And since they're interested in potassium carbonate, we're going to figure out the yield of potassium carbonate from 15.6 grams of carbon dioxide. That's step 1. And then in step 2, we'd figure out the yield of potassium carbonate from the other ingredient. What's the other ingredient in this? Yeah, potassium hydroxide. And then take the smaller amount. And so the analogy would be, let's say you can make, 100 cookies from the flour, but you only have enough sugar to make 10 cookies, then you're only going to make 10 cookies because you're going to run out of sugar. And so the sugar would be the limiting reactant, and 10 cookies would be the theoretical yield. And so what we got to do is, these numbers are a little bit abstract. I mean, it's hard to see which ones. Maybe it is. Maybe it's just the right amount. But we got to do the calculation to find out. So why don't you work on the calculation here?